Hello students, welcome to EduCell. In this video, we are going to discuss about weighted interval scheduling. As we have already discussed somehow about interval scheduling and interval partitioning in a greedy approach, here we will be doing the same thing using the dynamic approach. Why we are following dynamic approach, and if you are following greedy approach, whether we will get a solution or will expect the solution or not, that we will discuss in this video. So before starting this video, I must say I have collected this information from Tardo's book, or like the book which is written by Tardos and other co-authors. So here I've collected the information from the Tardos PPT. Okay, so those who are new, kindly watch the previous videos related to this interval scheduling, which is a part of greedy approach. You please uh, check that one. And else, if you are new to this dynamic approach, please start with the dynamic programming introduction, then subset sums and other videos which are waiting for it as a prerequisites. Okay, you please visit that one. You please read that one. Next, we'll start with it. So there are the jobs, you can say, or tasks, you can say. As we started with the interval scheduling, there we discussed about the tasks. Okay, so the same thing here also, but here one more thing we focused. Instead of just picking the compatible one, we are considering the maximum weight. It is clearly written here. Okay, so we will definitely get a compatible, but the compatible should have the maximum weight. We want the maximum compatible jobs or set of tasks which are to be done for our you can say it's a solution for us, but the goal or the aim is we want to find maximum with subset of mutually compatible jobs. Again, I must say what are compatible jobs. Like if we were picking suppose here these are the set of jobs. Okay, here S J stands for starting time of each job, and WJ is for the weight assigned to each task or each job. Fi stands for, or Fi represents the finishing time of that task. J stands for the task name or the representation of task as J. Okay, so you can say S1, W1, F1 also, because we are focusing on the first instruction or first job or first task, you can say. Okay, the name of the task is A, and here the weight is assigned. Okay, some of the weight is assigned as weight could be anything. Okay, weight we are just discussing weight. You can say there are certain projects. Okay, in real life, if I'll say such, there are certain projects which are to be completed, okay, by us, but we will focusing on those projects which are having the maximum profit that we are getting. We know if we will be doing that one, somehow we will be losing other projects. I understand that one. Okay, but somewhere we need to get a profit. We want to balance the profit. In that case, if you think we will be completing the jobs, means the compatible, means the non-overlapping one. I'll tell you those who are new again. I'll tell you that how do we say it's a compatible or non-compatible. So that we will be focusing on. Okay, but here our target is we will be completing those tasks which are not compatible. Okay, or which are, sorry, which are compatible, which are non-overlapping. We will be completing those jobs or those tasks or those projects, and we will get maximum profit out of it. Okay, this is what the real life implications of it. So here you can say if I pick A, so within that finishing time, a B is there, then C is there. Also D, somehow we started the D and it is not yet completed during this finishing time. E also somehow started. Now F is also somehow within this, timing. So if I'll pick A, then this has to be discarded, this has to be discarded, and this has to be discarded. Also, this has to be discarded. Then we will pick G. Why? Because the finishing time here is equivalent to the starting time of the next task, or else the starting time should be greater than the finishing time of the previous task. Then only we can say they are not overlapping. If not overlapping, then we say it's compatible. Compatible means non-overlapping. Non-overlapping. Okay. This is what the compatible means. So we want the compatible jobs which we already found using the greedy approach. But here we assign a maximum weight. Means those subset or those set of compatible jobs we want to find which will provide us the maximum weight. Okay. So here you can say if I'll pick A, we have option like we can pick G or H. But which one is giving us, these are two sets or two subsets. If I'll pick A as, suppose let us take the maximum it based on the maximum time it captures. Just think of it. So in this way, if I'll pick A, then I have two options for compatible sets. Either I can pick G or I can pick H. So in this way, which one to be picked, that we will be focusing. So, as earlier we have already studied the greedy approach. Greedy approach said, like you have to sort the finishing time. So, though we are sorting the finishing time, no doubt the time complexity is n log n that time also. Here we will get the same time complexity, but whether we are getting the correct answer or not, because our main target is the solution should be proper. Okay, though we are investing the time, definitely we need to know the solution should be proper, the exact solution. In greedy we recently studied, like in greedy we definitely get the probability is 0.5, means we may or may not get the optimal solution. But here in dynamic we are definitely getting it. So though we are definitely getting it, somewhere we have to manage the time, means somewhere we need to compensate with the space. That is why the memory is getting added in this dynamic one. So here how do we use it, that we'll be discussing. But let us just focusing on if we'll run the greedy, whether we are getting it or not. Okay, you say there are three different jobs have been attached here, like B, A, and H. We know the height is 1 and height is 1 here. Sorry, the weight assigned as 1, weight assigned as 1, and weight assigned as triple line. Okay. In our goal, we need to find the compatible jobs, but the maximum weight should be assigned. The weight should be maximum. Or you can say just forget about the weight, just think the profit should be maximum. Here the profit of the B, if I'll pick the B, the profit will be 99 $999. You just focus on that. So here these are the $1 projects. You know you have to complete within certain time. So if I'll pick B, definitely these two will be discarded. So as per our objective, 999 should be picked as the maximum weight, and the set or the compatible set should be B. But as for the greedy approach, we need to pick the less finishing time should be picked first. So as per this three, the less finishing time is, let us take three. Why? These are the just the time stamp have been added. So you can say these are 0 second, first 1 second, 2 second, 3 seconds. As for this, so 3 second is less than other seconds. So we have to pick this one. Though we have to pick as per the greedy, what exactly the problem we found. If I'll pick A, definitely I need to discard B. Only one option I have to pick is H. Why? Because these two sets are not overlapping or compatible set for us. If I'll add the weight, I'm just getting 2 is the maximum weight that we are expecting using the greedy approach. But here in dynamic, means if we'll use any other approach, we might get triple line. That is why we thought might be dynamic could help us in this regard. Okay, that's why we introduced this problem using the dynamic approach. I think you understood why we left with the greedy approach. As for the greedy approach, again I'm saying, as for the greedy approach, the low or the less finishing time will be picked first. Why? Because they are sorting the finishing time based on the finishing time sort. So they are picking the jobs as the compatible jobs. Okay, here our target is compatible, not an issue, but our main target is maximum weight. But whether we are getting the weight as maximum, here if I pick A, definitely this is a compatible job for us. We need to discard it for a while. So if I am discarding means I am not taking the weight, the maximum weight. That is where the problem arises. And I need to pick this H, no doubt, not an issue. So if I'll pick this weight, so 1 plus 1 is 2 and 2 is not greater than triple nine. That is why the problem we got in greedy approach. Okay. So let us focusing on the weighted interval using the dynamic programming concept. So here P of J and opt of J, these are three different things that we will be discussing now. So one is also W of J or WJ, you can say. WJ is weight weight of task J. So the task J, the WJ represents the weight of J, okay, and P of J represents the compatible sets, or you can say compatible set of jobs or tasks based on index. We will be discussing that one, don't worry about it. Just I'm writing it. Next, OPT, optimal J also you can say. OPT represents. Here it is clearly represent the maximum weight of any subset of mutually compatible jobs. Okay, so I must write this one. Do not write the same thing it is representing. Okay, so I'm just highlighting it. So this is what the opt J is. Okay, basically we try to find the maximum set of jobs which like the subset we will find our maximum set of compatible jobs where we got the maximum it. Okay, so we'll take this example here and we will be solving it here, like what exactly we are getting. First of all, we will be discussing how we will be finding P of J or Pj. Okay, Wj, let us take this example as you can say these are the weight assigned within that and these are the tasks from initial order. Okay, these are just the tasks from starting to the eighth one. Like there are 8 tasks and within that what are the written, you just think these are this is just an example for us. Okay, this is our W of J written within the task, as well as this is same task for us. Like the weight is one and let us take this as example for us. Okay, I'm not writing anything within that. I'm just discussing with the same value. I'm not writing anything. I'm not interested to make it garbage first. Okay, let us take the example. These are the one, two, three, whatever it is written. These are no doubt is a task for us, as well as I'm just pointing these are weight for us. Out of this, we know the compatible jobs. If I'll find out the compatible jobs based on the finishing time, it might be we have to just take care of it later. But if I'll pick one, so I have to discard uh, up to this and I need to, if I pick one, then 6 will be fixed as a compatible, another will not be compatible, because if I'll pick one, so up to this only I have two options, like sorry, we have three options. Out of these three options, anyone you can pick. Okay, so you just think as per the weight condition, if you pick one, so 8 could be picked as a maximum weight that we have. So 1 and 8 is 9, but 9 is not a maximum. Why? Because 3 plus 10 should be maximum is 10 as a weight we need to expect it. Okay. So now we should discuss about the P of J. Don't worry about it. Just step by step we will be discussing. So within that the numbers it is written, just think it's a weight for us and these are the tasks it is written. Okay. The first task, the weight assigned is 1. Okay. I'm just keeping one tabular format where we will be discussing it well. I'll be picking three different options for it. J stands for the tasks, WJ, then P of J, opt of J. Let's change it. No doubt J will be based on that. P of, sorry, W of J. That could be better and that could be very much easy to understand. Opt of J. So what we have to find out? There are 8 jobs. 8. Okay, there are 8 jobs. And okay. Now, based on the 8 jobs, the weight actually for each task we should write within that it is written. Let us take these are weight. The first one is 1, 2, 3, 4, 5, 6, 7, 8. But in the competitive exams or in other semester like exams, there it will be clearly mentioned the weight for each task. Okay. So here the starting time, ending time, and everything is being represented well, but in the question paper you will find the starting time, finishing time, and a weight assigned to each task. But here I'm just taking the same example, so I'm not changing anything. Now P of J, if I'm finding out P of this J, P of 1 will be above to each, above to that one, so no jobs are there or no tasks are there, so P of 1 will be 0. Okay, so above the task there are no other tasks where we will be comparing about the compatibility or not, compatibility of that job. Okay, so in this case we should say compatibility of the job 1 is not getting compared with other jobs above to it. Okay, so that's why I've written on index wise, based on index wise. So index means let us take this is one first index, this is second index, third index, fourth index, fifth index, sixth index, seventh and eighth index. Based on the index, we will be comparing. This is our index. Okay, index wise we will be comparing. Then P of J, which is 1 is 0 now. So we will be comparing, then at this condition we will be comparing with other, like for this second job there is one job, no doubt, but it's not compatible. Why? Because it's both are overlapping. So P of 2 is 0. Here P of 1 is 0. Now for P of 3, definitely two other jobs are waiting for it. The two other jobs are running within this time. So we cannot say these are compatible for it. So like this we are just trying to find out what is the value of P. Here we have three other options, but within that we found the initial time, like we have to compare with the above one. So 4 is compatible with 1. So I must say P of 4 is, or P4 is 1. Clear? So now for 5, P of 5, I must have to compare with other 4 tasks. So here all are compatible, so I must say it's 0. Okay, so I have to just compare with other jobs just before it. So here it is written I should be less than J. I means the index. We have to just compare with the index which is written there. Okay, so now we have to check for P6. So P6, definitely there are other 5 jobs, but we have to check how many compatible jobs could be possible. Here 2 and 1 are possible compatible for it. Like we will be picking either 6 with 1 or 6 with 2, but no doubt, but two tasks we have the options. These are the options basically. So for 6 we have two options. Why? Because here you can check, so here the finishing time is completed earlier or equivalent to the starting time of 6. So that is why we can say these two jobs could be expected in compatibility. So here in 7, P7, I must write, I have to check with this. So here we found 1, 2 and 3. Three options. Why? Because the finishing time here we say is equivalent to the 7. This will be fixed. And other finishing time is less than with the starting time output. Okay, so it's now 3. For P8 we have to check the starting time. Only one it is being compared with, which is 1. So that is why we can say P of 8 is 1. Now I just want to write it properly. So 0, it was 0, it was 0, then 1 0 2 3 1 1 0 2 3 1. Okay, now we have this formula which is said to be Bellman equation, where we are using this optimal and we are getting the maximum output, or sorry, maximum weight, by considering this set of compatible jobs. Okay, so here as for this OPT, the OPT it is written optimal J could be 0, and here I must write max OPT J minus 1 WJ plus OPT P of J. If J is 0, if J is greater than 0, it is written clearly, where if A is greater than 0. Okay, so for the base condition here, for this base condition, OPT 0 is 0. Why? Because J is 0, you put 0 here equal to 0. So this is what the base condition for us. I'm just changing the color for a while. I want to write for this OPT, this value I'm just writing. For this value, we have to write OPT J. Definitely we must write J is not 0 because the started J is already started. So here J is 1. Here J is 1, 2, 3, 4, 5, 6, 7, 8. J stands for the tasks. Okay, jobs or tasks, which represented as J. Okay, now for this J I must write it is 1. OPT 1 will be from maximum OPT 1 minus 1, which is considered as 0, W of 1. First time I'm writing the correct answers, then I'm just trying to first I'm just making it in detail, then I'll be focusing on the brief of it. Okay, so 1 minus 1, I'm just putting J in place of J, I'm putting 1. Okay, so next one, why? Because this is first job for us. Next OPT P of 1, in place of uh, J I'm just putting it max OPT 1 minus 1 is 0, W of 1, weight of 1 is 1, plus OPT P of J, P of 1 is 0, OPT 0, then max 0, OPT 0 stands like this is a base condition for us, 1 plus OPT 0 again this one, so maximum we have 0 comma 1. So here out of this max function we know the answer should be 1. Okay, now I'm just writing the answer here, the answer should be 1. Clear? So we have to use the OPT. Clear? Based on that we are finding the answers. I hope it is clearly understood to you. Next, for this condition I'm just writing it 2. Writing it 2, the OPT value now it is changing. Okay, so J is 2, J was previously 1, J is 2, 2 minus 1, then W of 2, then OPT 2 here I must write. So 2 minus 1 OPT 1, Next it is P of 2, P of 2 is 0, P of 2 is 0. Okay, this is P of 2 for us, P of 2. So P of 2 is 0. So I must write OPT, this one, the weight. So weight of this one is 2. This is our weight. Okay. So weight assigned here is 2. Next 2 plus OPT 0. OPT 0 is the best condition. Previously OPT 1. OPT 1 is this one. This one is OPT 1 for us. Clear? Means the previous value of it. So 1 comma 2 means one side is 1, left hand side is 1, this side is the right hand side is 2. Out of this we must write the answer here, which is 2. Clear? I hope it is clearly understood to you. In the example also you can check, if I'll pick the maximum weight, suppose these are the weight, if I'll pick this, out of these two options we know 2 is the maximum. If I'll pick only one single entity without any other entity, so we must say this entity will give us the maximum weight as 1. Because within that we are considering the weights, no? That is why. Okay. So I hope it is understood to you. Next we'll change the value to 3. Okay. So now the value will be changed to 3. So if j value is 3, here OPT 3, here 3 minus 1, here this is 3. So this P of 3 is this 0. Now P of 3 is 0 and this is 3. Weight of 3 is 3. 2 minus 3 minus 1 is 2. OPT 2. OPT 2 is 2. So I am writing OPT 2. This OPT 2 is here. Okay. So next is 3. For this one we are calculating the value. Okay. Now for 3 plus OPT 0, so 2 and 3, so maximum is 3 that you know. So the weight is 3. Here also if we'll pick this one, so we will get the answer as 3. Next, OPT value changed to 4. Is the 4, 4 minus 1, 4, and here is 4. 4 minus 1, this is 3, OPT 3, and here it is P of 4 is 1, OPT 1, and W of 4 is 4. Now PT3 is 3, this one. 3 I'm writing, 4 I'm just writing as usual, but OPT1 is this one. Okay, so OPT1 is 1. So out of 3 and 5, the maximum is 5. You can check it. If I'll pick, you just check it just for verification. If I'll pick fourth one, fourth up to 4, you can say the tasks, the maximum width whether it is 5 or not. Here you can check. If I'll pick up to 4, if I'll pick up to 4, here we will be saying this is compatible with the only one of tasks which is previously being started or might be completed. So with that one, if I consider the weight, it is 4 now, weight it is 1. So 4 plus 1 is 5. No other jobs could be considered here. If I'll pick 3 also, no other will be considered. So 3 will be maximum, which is not exactly maximum we are getting. So we will use this optimal OPTJ, then we are getting the correct answer using this, dynamic programming. So this is how we are getting the answers. Next, you can say we're getting other answers, like others are also waiting for us. I think it's understood. Here you can you can write J5 for J5. You write it here 5, 5. This is 4, and here for this 5, you can write here 5. So the weight assigned for 5 is 5 plus OPT 5 is 0. So you just write 0. This P5 represents this one. So it's 0. So just write 0. 5 plus 0 and OPT 4 is 5. So out of 5 and 5 the maximum will be 5. So if you consider the fifth one also, you are getting the same answers. Now 6, here it is 6. 6 minus 1 is 5. So I am here considering this as 6. This is 6. If you are considering 6, OPT5, this weight of the 6 is 6. 6 is 2. OPT2, OPT2 means this one. So 6 plus 2 is 8. I'm writing 8 there. And OPT5 is this one, so which is 5. So out of 5 and 8, the maximum we are getting is 8. Okay, if you consider 8th one also, you will be getting the answer as 8. Okay. So you just compare this one up to this first one. If I'll pick, so I know like we have two other options. Either 6 will be combining with 1 or 6 will be combining with 2. So if I'll combining these two compatible jobs, so here the weights you can add this weight because the jobs is equivalent to the weight here as per the example. So here the weight could be 7 and here the weight could be 8. So we are getting 8 now. So that is what we are getting the correct answer somehow. So this is you can say we are getting the correct answers for this OPT whichever that we found. Next you can say J value as 7. Now for J value 7, here OPT 7, here I am putting 7, here 7 and here 7. So OPT 7, this is OPT 6 which is 8. Now I am writing for this value and this weight, this weight of this 7 is 7 and OPT 7 is 3, this one. Okay, because P of J is 3. So within that I am just writing this OPT 3 and OPT 3 is this 3. So 7 plus 3 which is 10. So out of 8 and 10 the correct value or the maximum value which we are expecting is the maximum value is out of 8 and 10 it is 10. Okay. Next we what we expected we are getting the values now. Now the J value is 8. If the J value is 8, OPT J 8 minus 1 is 7, OPT 7 is 10. Now here it is 8, here it is 8, 8 plus OPT 1. Why? Because P of 8 is 1, P of 8 is 1. So that is why we are writing, and OPT 1 stands for this. To there 8 plus 2 which is 10 comma 10 means out of this maximum is 10. This is how we got the answers. Okay. So I hope it is clearly understood by you, through which we are getting the maximum weight which we expected. Okay, so here you can say the maximum weight first is 8. If I'll pick with this 8, we thought 8 plus 1 is 9, but this is not correct. We know 3. If I'll pick 3, 7 is also there. So if you count this, 3 plus 7 is 10. So we can say the weight assigned with there is 10. 10 is maximum and other things. So that is what we exactly considered and we followed that one. Okay. Now here we compared with the brute force one. I'm just changing the color now. So we compared the brute force method. As for the brute force, we know we have read the top-down approach, or the functions which are calling repeatedly is called recursion. If you are using recursion, it is memorization. Memorization follows the top-down approach. To get 5, we have to know what is 4 and what is 3. Like these are the overlapping subproblems concept. So overlapping subproblem could be solved in dynamic one. So we need to solve this one, again we need to solve this one. To optimize that, we are using dynamic one. So that is what the problem is in a recursion tree. In brute force approach, definitely we are getting it, but the time complexity is more. So here we are using memory, na? So why we are wasting the time there? We will store it and we'll use that one. So here m is getting introduced, just an array that we have used, because I told you whenever we are focusing on a memory, we are using an array, because there is no such constants. Other data structures are also there, but constants are being attached here. Okay, so to avoid the constants, we are using simply array. So here we just use the condition which recently we studied, like OPT concept. Okay, M stands for the OPT one. So here M of 0 is 0 because it's initial one, or like you can say the base condition. Here as for the J, if it is uninitialized, okay, or not initialized, the same OPT is getting used. Here you can check one. Okay, so the same thing we are using, but in coded format we are writing, and this is top-down approach we are following. Okay, this is how we are reducing the time complexity. No doubt, the time complexity is similar as compared to that the greedy approach. But one more thing we are considering, we are getting the optimal solution. Though we are compromising with the space, no doubt, space we have given, through the space we are trying to optimize this answer optimality. You can say the correct answer we are getting as 100%. Probability is 100% that we said. The probability is 1, means we are getting the correct answers. Whether we are somehow losing the space, because space compromisation is there in a dynamic one. But greedy, no space we are taking, but the probability is zero point 0.5, means getting the correct answer may or may not. In that case, we are following. So here, definitely when we are sorting it, here you can say sort the job in finishing wise, then we compute using the binary search. So here the same thing it is written. So though we are using the binary search, so it is running for n log n, and overally that the we are using the array. So that is why when we are computing it, it's n. But overally the time complexity, if you ask me, the time complexity could be the maximum we are taking. Complexity would be big of n log n, but here we are getting the correct answer. The probability is 1. Okay, the probability is 1. This is how we discussed in detail about the weighted interval scheduling. If you need doubt, please comment below. Thank you for watching. Have a good day.